Hello, welcome to Algebra 2A. In this summer packet, you're going to watch a series of 5 videos. With each video, you're going to follow along, filling in the packet as you go. So make sure you have the printed packet ready to fill in. In the end, you'll have the entire summer packet filled in and all 5 videos watched and have that ready for the first days of school. If there are any questions, feel free to email Mrs. Reed at the email here. So let's begin the first section. This first video will be on factoring polynomials. So I'm first going to fill in about the topic and the definitions and notes section. Okay, here you can see that I filled in each of the boxes. Now let's try the examples together. For the first topic, GCF, you'll notice there's multiple terms here. And what we're going to do is we're going to look at each of the terms and decide the greatest common factor that can come out. We can't take an x out everywhere, but we can take a number, and the GCF of 6, 18, and 24 will be 6. So what we're going to do is divide each term by 6. That leaves us with x squared minus 3x plus 4. What's really nice about factoring is you can always check your answers by multiplying it back. So if I distribute the 6 back through, I'll get 6x squared minus 18x plus 24, which is what I started with, so I kind of know I did it correct. The next topic, an easy trinomial. You'll notice that we're going to have 3 terms and no number in front of x squared. That's what makes it easy. So what you're going to do is start by making 2 sets of parentheses. In the front, x times x will make x squared. Now we're going to look at factors of the constant 10 that combine to give us the middle term negative 3. So factors of 10, 1 and 10, or 2 and 5. I'm going to use 2 and 5. If I make the 5 negative and add 2 to it, I will be left over with negative 3 in my middle term. Again, you could FOIL this out or just distribute to check that this will be correct. Next, we're going to look at hard trinomial. Again, this will be 3 terms, but this time we're going to have a number in front of the x squared. There are many different teaching methods, so you're going to want to choose the one that you're most comfortable with. There's methods like guess and check, AC method, which is like first times last, box method, and others. Alright, so I'm going to show the A times C method, or the first times last method, for our example here. So what you're going to do is take the first coefficient and multiply it to the constant term. That gives us 6. So now you want factors of 6 that add to the middle term 7. And those factors will be 1 times 6. So what we're going to do is split the 7x into 1x and a 6x. And it doesn't matter which one comes first. Carry down the 2x squared and the 3. Now we have 4 terms. You want to group up the first 2 and the last 2. Looking at the first group, take out a GCF. The GCF here will be an x. We can take an x out. And if I do, I'm left with 2x plus a 1. Looking at the second group, I could take a GCF out of 3, and that leaves me with 2x plus 1. I know I'm doing it correct because these two are the same, and you want them to be the same. You'll then have 2x plus 1 as one of your factors, and the GCFs will make up the other factor, x plus 3. And this will be our complete factored answer. Again, you could multiply it out to check that you did it correct. Let's look at the next topic, difference of squares. You'll notice this is only 2 terms, and you're going to notice perfect squares in the problem. You're going to break it down into 2 parentheses. So looking at my example, I'm going to draw 2 sets of parentheses. Notice that x squared is a perfect square, and 81 is also a perfect square. So take the square root of each. The square root of x squared is x. The square root of 81 is 9, and you're going to make one sign a plus and one sign a minus, and you're finished. Notice there's no such thing as a sum of 2 squares, so this cannot be factored. Can't factor if it's a plus. It's got to be a difference. It's going to have a minus here, and our signs will be a plus and a minus. Our next topic is factor by grouping. You'll do this when you see 4 terms. So what we're going to do is group the terms, take out GCF, and then go ahead and regroup. So notice this example has 4 terms. So group up the first 2 and the last 2. In the first grouping, we can take a GCF out of not only a 3, but a 3x squared. When I divide that out, I'm left with x plus 2. In the second grouping, I can take out a 4, a positive 4. That leaves me with x plus 2 again. This is good. I know since these two are correct or the same, that'll be your first factor, and your other factor will be the GCFs that you pulled out, 3x squared plus 4. Our last topic is factoring completely, and basically you're going to look for a GCF, and after you've factored once, you're most likely going to be able to factor again. So in our example, I notice I can take a GCF of a 3 out. So I take out my 3, and I'm left with x squared minus x minus 12. Notice the trinomial I have left is an easy trinomial and can be factored again. Remember, easy trinomials break down into 2 parentheses. I put the x's in front, and then I think of factors of 12 that subtract to equal -1. And that'll be a -4 and a positive 3. Now that we've gone through each of the topics, the definitions, and the examples, try the practice problems at the bottom of the page.